Chapter 11 is all about sequences and series, and in lesson 11.1 we're specifically going to be talking about arithmetic sequences. So let's go ahead and check these out. So our notes say a sequence is a list of numbers in a particular order. Each number in this list is called a term. And then the first term would be symbolized by a sub 1, the second term is a sub 2, and so on. So if we have this example here, we're looking at the list 3, 5, 7, 9, 11. That would be a sequence where a sub 1, or the first term, is 3, the second term is 5, the third term is 7, the fourth term is 9, and so on. This particular kind of sequence would be called an, drew all over that, arithmetic sequence. It's called arithmetic because each term is as they change, they're counting by the same exact amount to get to the next one. And that change in between each one, that same, what we're counting by, is the common difference. So let's say we wanted to start at 5, and we wanted to count by 4. So we'd go 5, 9, 13, 17, and so on. So we'd say a sub 1 equals 5. A sub 2 equals 9, and so on. We could count all those out. We'd say our D, in this case, what we're counting by, is 4. So kind of like Mr. Count over here, we're just determining where we're starting from, our A sub 1, and we know how much we count by, 4. As long as we're counting by the same amount each time, 4, 4, 4, 4, it's an arithmetic sequence. So if we were asked to find the common difference and then use it to find the next term of these sequences. So in this case, 2 to 5 is 3, 5 to 8 is also 3, 8 to 11 is also 3, so it looks like our common difference in this case is 3. So then from 11, counting 3 more, we get to 14, 14 going 3 more, get us to 17, 17 going 3 more, would get us to 20, and 20 going 3 more would get us to 23. So that's how we would use what we have already. We'd find the common difference right here and just continue counting by that. So in this case, we're starting with negative numbers, but each time we're counting by the same amount. We're counting 2, going 2 up each time. So going 2 up from negative 1 would be at 1, another 2 would be 3, then 5, then 7, because each time we're counting by 2. And in this last case here, 13 to 9 is negative 4, 9 to 5 is another negative 4, 5 to 1 is another negative 4. I'm going to come down here, so if we had 1 where we started with, we go another negative 4, that puts us at negative 3, negative 7, negative 11, and negative 15. Again, each time we go, we're counting by negative 4. So we'd say D, in this case, our common difference is negative 4. I don't think I wrote it on this other one. Oh, back here. This one, our D is 2. So if we were given a sequence such as 1, 3, 7, 9, 10, we were asked, is this an arithmetic sequence? Well, right here we'd have 2. Here all of a sudden we have 4. Here we have 2 again. Here we have 1. You would have to say, no, it is not an arithmetic sequence because it doesn't have that common difference. Each time there's a difference for sure, but they're not common. They're not the same. So this one would not be an arithmetic sequence. All these other ones, they count by the same amount each time, and they continue. So that's how you could tell what is and what is not an arithmetic sequence. And in our next lesson, we'll look at geometric sequences. We'll see what those look like and how those go. So it is possible to find an equation for the arithmetic sequences. Now if we look back at our first one where we had 3, 5, 7, 9, 11, we can see that the common difference between all of those is 2. Because again, 3 to 5 is 2, 5 to 7, 2, 7 to 9. It's another common difference of 2. Our first term that we started with was 3. So anytime we want an equation if we're trying to create an equation for a sequence, we want to be able to use a sub n so that we can plug in whatever term we want, n. So say we have all these terms here, but we want to know what is the 20th term. So if we're looking for the 20th position, instead of counting all the way out 3, 5, 7, 9, 11, 13, 15, and continuing on and on and on, we could make a formula or an equation in this term. So it would be a sub n equals something that is continuously happening to n. So let's see exactly how we're going to find that. If we want this a sub n equals something happening to our n, we know that to go from our first term, 3, and if we want to go to, well, I'll call it 1 up here for first term, our second term is 5, we had to add 2. That's our common difference. So we could say that we took our first term and we added 1 of our difference. To go to our third term, though, to get to 7, from 3 to 7, we had to add 4, which is the same as saying we added 2 differences. Because each common difference is 2, so we went 1 here and 1 more here. Same thing if we go on to our fourth one, which is 9. To come all the way over, we had to add 3 differences. So from 3 to 9, it's actually a change of 6. We had to add 6, which is 3 differences. So we could say that we started with a sub 1, we started with our 3, and depending on which term we're looking for, if we're looking for the fourth term, it's 3 differences. If we're looking for the third term, it's 2 differences. So then we would add whatever term we're looking for, n, minus 1 times our difference. So again, notice how to get to our second one, it was 1 difference. 2 and 1, 3 and 2, 4 and 3. So we take our first term, add whatever term we're looking for, minus 1 times d. So in this case, we would say a sub n equals 3 plus n minus 1 times d, which is 2. So this is going to be our equation or our formula to find that. So again, let's go back to what I had asked. We said we want, a sub 20. We want our 20th term equals 3 plus 20 minus 1 times 2. So we'd simplify that down and say 3 plus 19 times 2. I'll have us come over here then. And that equals 3 plus 19 times 2 is going to be 38. So we'd say in the end then the 20th term, actually I'll just write it as a sub 20 equals 41. So you could count it all the way out and say 3, 5, 7, 9, 11, 13, 15 and keep going and find the 20th that way, or you can just find this equation and you can plug in for any value you want, any term. You can find the 100th term this way. So let's see an example. Just like everyone on planet Earth, Mr. Anderson gets paid based on how much math he knows. So obviously he's a multi-trillionaire. After high school, he started collecting Ferraris. He got the same amount more every year. So 1 year after high school, he had 4 Ferraris. 2 years after high school, he had 7 Ferraris. 3 years after high school, he had 10 Ferraris. And that continued, the same amount each year. So if we want to find an equation to model how many Ferraris Mr. Anderson has after n years, then we want to use that to find how many he has after 20 years. So remember, we use a sub n equals a sub 1 plus n minus 1 times our common difference d. Well, each time from 4 to 7, 7 to 10, 10 to 13, our common difference is 3. Mr. Anderson's getting 3 more Ferraris every year. So this piece becomes 3. In fact, I'll just plug a sub n equals our a sub 1, this term over here, is 4. He starts with 4 that first year. And we don't know exactly what we're looking for quite yet. We just know we're using n minus 1. So this is our equation. You really only need to know the first term, our a sub 1, and your common difference to make your equation. From here, though, now if you want to find a sub 20, so how many he has after 20 years, now is where you have to plug everything in. So 4 plus 20, this is our a sub 20, minus 1 times 3. Okay, so we'd say then 4 plus 19 times 3, which is 4 plus 19 times 3 is going to be 57. And 4 plus 57 equals 61. So a sub 20 equals 61. After 20 years, Mr. Anderson will have 61 Ferraris in his garage. Pretty cool. Sometimes, when looking at our arithmetic sequences, we may not be given 2 terms that are necessarily back-to-back. We'll still be given 2 terms. They won't necessarily be right next to each other, though. So we might have like, oops, move that right away. We might have 1 blank 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 19, and we need to find what these blank pieces are. These in-between pieces are called arithmetic means. So anytime we are asking to find arithmetic means, it's these blank pieces right here. So in this arithmetic sequence we're looking at down here, if we've got 19, 30, 41, 52, 63, 74, 85, if we're looking at 30 and 74, we'd say that the 3 arithmetic means in between them are 41, 52, and 63. So if we need to actually find what these arithmetic means are, it'll be helpful to find a formula or an equation for our sequence first. So if our sequence, if we're looking for the 4 arithmetic means in between 16 and 91. So it looks like this, goes 16, blank, 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 91. We can say then our a sub 1 is 16, and our a sub 6 is 91. Now we know we want to get our equation into a sub n equals a sub 1 plus n minus 1 times d. So we just plug in everything we know. We know we have a sub n that is a sub 6, and that's 91. So we would say a sub n, or a sub 6, or 91, is a sub 1, which is 16. So that came from there, that came from there, plus n, which is going to be 6, is our a sub n, or our a sub number is 6 in this case, minus 1. And our common difference, that's the piece that we don't know quite yet. So we'll leave that as d. We're trying to solve for d in this case. So we put our a sub n, a sub 1, and our n, because those are the pieces we know. So from here we say 91 equals 16 plus 6 minus n d. 16 plus 6 minus 1 is 5 times d. So we have to take 16 away from both sides. Minus 16, minus 16. So we are left with 75. 75 equals 5D. Divide each side by 5, in which case we are left with 15 equals D. So now we know our common difference. So we could either plug that back into our formula and say a sub n equals 16 plus n minus 1 times 15, and plug in 2, 3, 4, and 5 into our n values, or we can just start with 16 and count by 15 each time. So we would say 16, another 15 would give us 31, another 15 would give us 46, another 15 would give us 61, another 15 would give us 76, and another 15 would get us to that 91. So then our four arithmetic means are going to be 31, 46, 61, and 76. So that's everything you should need to know about arithmetic sequences.